Okay, so this deal with significant figures should be something new to you unless you had Burgess last year. And if you had Burgess last year, you may have been in her class where she taught about something called significant digits. So it's the same thing, but in science, it's a concrete set of rules that you have to follow about rounding. When we round our answers, when we do math, there's a set of rules we have to follow. And in order to know the rules, you have to learn about what's considered significant or not. So this word significant just means to you it's important, right? That number is important. So it says, in science, there are a set of rules about measurements and math. Every scientist in the world uses these same rules because even if I'm a scientist in France or Mexico or Cuba or Germany or Russia, I want to use the same set of rules when I'm doing math in science so that everybody in the world is doing it the same way, right? Everybody's got to be doing their math the same way. So here are the rules, and I just shorten them. When you see me call them figs, I'm just shortening this word significant figures, right? So here are the rules. Rule number 1, anytime you have a measurement, anything that is a non-zero number is considered significant. And when I say significant, that just means if I have a measurement like 129 grams, that's my measurement, 129 grams. Are all of the digits in that measurement numbers, actual numbers, not zeros? Yes? So that means if I'm going to count how many of those numbers in that measurement are significant, and I would say this one is significant, this one is significant, and this one is significant. So this one has 3 significant figures. That's what I'm saying, okay? So anything that's a 1 through a 9 would count as significant. The next 3 rules are about zeros. So this first rule is about zeros between actual numbers. You're going to want to write this in. Actual numbers 1 through 9. So any zeros between numbers 1 through 9 are always significant. So if I give you an example, that would look like this. 3,002 milliliters. My 3 is a non-zero number, right? It's a 1 through 9, so it counts. The 2 obviously is a number, so it counts. So what's the deal with these zeros? Well, they're between 2 numbers, so they would count. So I would look at this and say the 3 counts, the 2 zeros count, and the 2 counts. So this measurement has 4 significant figures. That's what we're doing. You're actually just counting how many of the things in that measurement are significant. So that's about zeros between. They always count. The next rule is about what we call preceding or leading zeros. They are in the front of a measurement and they are never significant. So in your Edpuzzle video, you watch this thing about the Pacific and Atlantic with the United States and which way to count. You just have to remember this rule. Look at this example. If I have zeros in the front of a number like this, 0.0002, none of these zeros would count as significant. I would not count them when I'm getting ready to do my rounding, right? I would just say none of the zeros in the front count, even these ones behind the decimal. They're still in the front and they're still preceding. So I just mark all the way through them. They don't count. This 2 is the only thing that counts. So I would say this number has 1 significant figure. Right? We're going to look at lots of examples in just a minute. My trailing zeros. Trailing zeros are at the end of a number. And they are only significant if there is a physical decimal anywhere in the number. So the examples you might have seen on your Edpuzzle look like this. when you have zeros at the end, these are your trailing zeros. They're zeros at the end, and they can only count if I see a decimal. So the first thing you do is look for a decimal. Do you see a decimal in this number? Yes, I see a decimal right here. That means that this zero that's trailing would count. Zeros in the front, however, never count. So this measurement would have 2 significant figures. Look at this number. Do you see a decimal? No, you have to physically see the decimal. And since you don't see a decimal, those can't count. So this one only has 1 significant figure. So what I'm going to let you do is, I'm going to pause the video. I'm going to let you copy some more examples about each one, and we're going to talk about lots of different examples, and then we're going to practice in class.